GitHub Terms and Concepts. GitHub is a popular website and service providing version control access for code development. It uses the command line tool Git, which is a software suite designed for distributed version control. This is where repositories, collections of code, are both their own clients and their own servers. This gets us away from previous software where there would be a server or a collection of servers, and then there would be client code that would then talk to these servers. Git, as a software suite and command line tool, moves away from that into a distributed model where each repository is its own collection and is both, again, its own client and server, which means it can take care of itself and, of course, can communicate to other repositories to distribute changes across them. However, it comes with its own sets of terms and concepts we want to get into so we understand and can talk about the vocabulary GitHub uses being based on Git. Let's start with the term repository. So this is a collection of code. It could be data, it could be source code, could be combinations of the two. Each project usually is its own repository. So this is often abbreviated as a repo. And in fact, you will hear me use that term repeatedly across this video as a repo for a repository, otherwise known as just a collection of code. An important term when talking about repos is a fork. So creating a new repository based on an existing one is called forking. Each new version is a fork of the original. Now, I use the word version here because it's important to talk about both creating repositories and some additional terms we're going to get into later in this video where it is a copy of a repository for a different purpose. So a new version is a fork of the original. So when we fork code, again, we're taking the original repository and creating a copy of it. Once we have a copy, though, we can start to talk about changes that are made to each of these and how they relate to each other. A commit is a set of changes made to files in a repository. Each has a summary and a description. So as we're working on code then, we're going to be submitting commits. Again, a submit is a set of changes. When we submit a commit, we will have a summary, basically what was done for those changes, and a longer description. Think of the summary as a short way of saying something like updated files or fixed a certain issue. Something that's very easy, again, a summary of those changes. Description could go into a longer form of I made these changes for these reasons, or I'm fixing this, or something like that. So again, a set of changes. So this could be a single change for a file, or it could be changes to hundreds or tens of thousands of files. It's all in how we want to adjust these and consider those changes. So again, we have a summary and a description of a commit. Now, when we're thinking longer term, when all of these are applied to a repo, that is, we apply a commit, we then have a series of commits. So all of the commits, all of the sets of changes made to a repo, are a listing of all of the changes, when they happened, who made them, and exactly what they were across the history of a repo. This helps us then both go forward and backward in time when looking at code changes. We can, looking at the commits of a repo, actually rewind to a previous version. Hence the use of version control in this sense. So if we run into a major problem, we actually need to rewind to a previous commit, we can do that. One way to think about commits then is whenever we save a file. An example might be, as people are more familiar, using Microsoft Word, where it saves different versions of a file. And numerous other services, for example, the Google Suite set of programs online for writing documents often save different versions across sessions. This is a very similar idea, again, thinking of a commit as both a summary and a description of those changes. So then, as we're talking about commits, we can talk about two primary verbs we use to describe commits in relation to repositories. So we use the terms pull and push. A commit is pushed when it is sent to another repository, and it is pulled when it is, again, pulled from other repositories. So this is important because in looking at two different repositories, we care about these relationships. Because again, a repository is both its own client and its own server. So it does not exist in a relationship necessarily where one repository is better than another. Instead, it exists in a distributed sense, and so we can push commits from one repository to another to suggest some changes, or pull in those changes, again, this series of commits, from another repository for ours. Again, it exists in a distributed sense, and we can pull and push commits across them. This tends to make a little more sense, especially commits and pull and push, when we look at them in practice, as we'll do in later videos, but these are important terms when considering this. We also need to start to think about versions of code. Again, I used that word earlier when we were talking about repositories to talk about versions of code. So some repositories may have multiple branches. One way to think about this is projects that have, for example, a 1.0 or a 2.0 versions of their product. And so then we can think about projects with different branches of their code. In these senses, we can push commits to each separate branch. That is, commits don't have to necessarily go to a single branch of code and could go to other branches of code. We can also compare branches of code and work across them. Again, which is why I mentioned version when I mentioned repo earlier, because each branch is, in a way, its own repo, but kept under a single project. So we have then different repos, different branches, this individual term within this, as we're looking at all of these. GitHub also uses this term pull request. So because GitHub is a website and service, then it needed to create a term to describe the process of asking another project, or another repo in this case, to apply some changes developed in another repo. That is, I've created some changes and I'm submitting them to another repo and said, hey, I would like you to pull this code. So in other words, a pull request, pulling those commits from one repo to another. So in GitHub terminology, this is a request made to apply one or more commits from one repo to another, and again is often used to submit code updates from one repo or branch, again we can work across branches, to another. This usually makes more sense when we actually look at the site and look at how it uses this terminology, pull requests, especially in terms of another word, merge. So if we're dealing with pull requests in GitHub, we're asking to apply, again, commits, sets of changes from either one branch to another or from one repo to another, across branches perhaps. So again, think about branches as sort of internal copies within a project. So we might have multiple branches, or we might have multiple repos. So code is merged when commits, again, sets of changes, usually in the form of pushing and pulling, again, we're thinking of those verbs as we're dealing with commits, are applied to a repo. In GitHub, these occur as part of pull requests. Again, pull requests are requests to pull in sets of changes, pull in commits from another repo or another branch. So this is where a user makes a request for changes made, and then if they agree to those changes, the term merge or merged is used to describe applying all of those changes from one branch to another or from one repo to another. So we are applying all of those changes and we're saying, yes, I agree. I would like my code to match this other code, and we are merging those changes. Again, this is very common, the terminology used in, for example, Microsoft Word or other projects like that, where we use the term merge to think about cross changes. We are merging changes together. Or if you prefer, in a program like Photoshop or other editing software like that, where you are merging layers. So you've got all of these different changes and you're putting them all together, or merging all these changes. So the term clone is used when a repo is copied locally. So again, when we're talking about repos, and especially talking about Git, they exist in a distributed sense, in that one repo is not necessarily more important than the other, and they can submit changes across them, again using the verbs pull and push to describe sets of changes, commits. So when we're talking about then working with code on a local computer, we use the term clone to describe the process of making a local copy on a system, usually a desktop or laptop device, and then submitting it to a remote location. In the case of GitHub itself, usually clone is used to describe the process of creating a local copy, for example, on a desktop computer, and then submitting commits to a remote location, that is, the GitHub service and website itself. So changes are made locally and submitted to the remote location. But again, they just exist in a relationship where they are distributed, so both are its own clients and its own servers. So again, clone is where we make a local copy. Tools like GitHub Desktop, which is of course used with GitHub, and of course the command line tool Git, again a software suite for working with Git-based projects. Clone repos for developers to then submit commits, as I mentioned, made locally to a remote source. So finally, we use this term base or rebased to describe when one repo is synchronized with another. This is particularly important when we have forks of projects. So we might have a fork of a repo that exists over on one thing and a fork that exists on another, and then the original. So if we ever want one of those copies, one of those forks of a repo to be matched with the original, we use the term rebased. That is, they become resynchronized with the original based repo. So one way to think about this is when we're describing commits that exist, that is, changes that exist between the new repo and the original one. This can sometimes happen, for example, if someone makes a copy of a project and then they are working on the project where another person or a team of people are working on another repo. So the code base is the same, they're working with the same base code, but, for example, one might be ahead or behind another. And we use this terminology, ahead or behind, to describe the relationship or the changes and they're merging across these two different repos. So for example, the original project might move to a new version number, let's say for example 1.2.3, whereas the other example of a repo might be at 1.2.2. So if we wanted to make sure they were both at 1.2.3, we would then rebase them. That is, we would synchronize those changes and we would merge those commits, all of the sets of changes, across both repos. Again, think about it in a distributed sense. If I have changes you don't have, we can rebase. That is, you can set your repo back to whatever mine was, or I could set mine back to whatever yours was, and we could keep them synchronized together. So let's go over everything we've talked about in this video. So GitHub uses a lot of terminology that's based on Git. Primarily, this concerns about distributed version control. And we care about repositories, that is, repos as a shorthand of saying that. We also deal with the verbs pushing and pulling. These deal with commits, and commits are just sets of changes. And so when we're looking across a project, we're looking at a series of commits. And then we look at those commits again in different ways, that they could be ahead or behind when looking across repos. And we care about things like branches, which are versions of a repo within its own project. And we care about things like rebasing, or in this case, a base, to describe the relationship between one repo and another. So it's a lot of existing terminology, but again, not too complicated, as we primarily deal with repositories, collections of code, and we deal with commits, sets of changes. How those commits exist across repos is where other terminology like base, rebased, push, and pull all come into play.